So today we're going to apply what we learned about complex numbers to help us divide complex numbers. So dividing complex numbers, so when we do the 8 plus 3i divided by the 1 minus 2i, my big question is, why can't I leave it like it is? Because it looks like it's simplified to me, right? Well, this is why, guys. Doesn't this, so we've got 8 plus 3i up here. We got 1 minus 2. Isn't this the square root of -1? I told y'all that you cannot have a radical in the denominator, right? That's why we have to simplify this more, because we have to get rid of the I that's in the denominator. So when we're dividing complex numbers, in order to simplify a fractional complex number, we have to use this thing called a conjugate. Big question is, what is a conjugate? So a conjugate's when you change the imaginary part of a complex number. So a plus bi is a complex number. If we change the sign of the imaginary part, we get a minus bi, which is the conjugate of a plus bi. So we're only talking about the imaginary part here, y'all. So that means we're talking about changing that plus to a minus. And that's all we're doing, y'all, is changing the sign. So if we look at these examples, and we've got conjugates, we got a minus bi and a plus bi, so the conjugates of each other. So when we continue through this thought process, we're going to do, 5 plus 3i and 5 minus 3i, -2 minus 3i, and -2 plus 3i. And then we've got the 10i and the -10i. So what you should notice here is that the only thing that's changing in these problems is the sign of the imaginary part of the problem. So hopefully you see that. Notice here, plus to minus, minus to plus. And there's a plus in front of that 10i, and there's our minus. So on your notes, you were supposed to match these with their conjugates. So on the left, we have the complex number. On the right, we have its conjugate. So if we're looking at -5 minus 6i, then we should be looking for -5 plus 6i. Y'all see that? We've got positive 4i, which would be matched with -4i. Then we have 5 minus 6i. Yes, it's moving very slow. So that's going to match with 5 plus 6i. And then we got -2 plus 7i, which will match with -2 minus 7i. Now this last one is a 3 and a 3. And the reason why the sign doesn't change here is because these are the real parts of the number. There was no imaginary part. So when we're dividing complex numbers, we cannot have any imaginary number in the denominator. We already talked about that. So we have to multiply the numerator and the denominator by the conjugate of the denominator. Remember, the denominator means the number that's on the bottom. So let's just go ahead and give this a try. So the complex conjugate of 1 plus I is 1 minus I. So what we're going to do is we're going to put 1 minus I over 1 minus I, and that's because anything over itself is 1, right? So now we're going to distribute. So we're going to do 5 times 1 minus I, and that equals 5 minus 5i, right? That's the top. Then on the bottom, we're going to do 1 plus I times 1 minus I. Okay, we could use the box method to do this. If you guys want to and feel more comfortable with that, then that's what you should do. We got 1 and I up here and 1 and minus I down here. So we multiply 1 times 1, we get 1. This would be, that's supposed to be a minus I, y'all. Minus I, this would be positive I, and then this would be minus I squared, because it's -I times an I. I want to bring something to your attention right now. You should see that we're always going to find our like terms in that diagonal. And in this case, these two terms cancel each other out, which they always will. when we are multiplying a conjugate times its complex counterpart. Okay, so this is going to then be 1 minus I squared. Well, you should know that I squared is -1. So this 1 minus a minus 1, which is 1 plus 1, which equals 2. So this was our numerator, 5 minus 5I, and this is our denominator, 2. So that's our answer. So over here on the next one, we're again going to multiply the top and the bottom by the complex conjugate. So that's -4I over -4I. 3 times -4I is -12I. When we multiply 4I times -4I, that's going to be -16I squared. Once again, we can replace that I squared with what? A -1. So this gets us -12I over +16. Is that the answer? No, because these can both be reduced by a factor of 4. The greatest common factor is 4. So we're going to divide both by 4. That's going to give us -3I over 4. And that is our answer, y'all. Okay? So these next two problems are going to be a little more complicated because we're going to have two binomials multiplied by each other on both the numerator and the denominator. So here again, we're going to put 1 plus 2I over 1 plus 2I. Again, we're only changing the sign of the imaginary part. So now when I do this, I'm going to actually use my box here to do this. I'm going to put 8 and 3I up here, 1 and 2I here. So get 1 times 8, that's 8. 8 times 2I, that's 16I. 3I times 1 is 3I. 3 times 2 is 6, and this is going to be 6I squared. Again, recall that we have our like terms right here, right? So these two are going to combine. So when we talk about what we get here, we're going to get 8 plus 19I plus 6I squared. Recall again that that I squared can be changed to a -1. This is going to be 8 plus 19I plus 16 times a -1. That's going to be 8. That's going to be -16, right? Sorry, not 16, but 6. Not bad, y'all. That should be 6 times -1. So that's going to be 8 minus 6 plus 19I. So our numerator is going to be 2 plus 19I. So I'm going to go ahead and put that up here. 2 plus 19I. Now we got to find our denominator. So I'm going to use, again, these two terms, 1 plus 2I and 1 minus 2I. Okay, so that's what we're going to do down here. I'm going to use the box method again. 1 plus 2I, 1 minus 2I. 1 times 1 is 1. 1 times -2I is -2I. 1 times 2I is 2I. Down here we got -4I squared. Again, hopefully you notice in the diagonal, these terms are canceling each other out. So what are we left with? 1 minus 4I squared, right? So that's going to be 1 minus 4 times a -1. So that's going to be 1 plus 4, which is 5. And that is our denominator. So there's our answer. Okay, let's see if y'all can do the next one. Pause the video, come back to me after you've completed it, and we'll see if you did it right. Okay, so I'm going to do 2 minus 2I over 2 minus 2I. Again, I'm going to use that box method. Seems to be pretty effective for you guys. So we're going to do 3 and 2I and 2 minus 2I. 3 times 2 is 6. 3 times -2I is -6I. And then we got 2 times 2I, that's going to be 4I. And then we got -4I squared. Like terms again in the diagonal. Y'all notice these like terms right here? So we're going to combine these. So that's going to give me 6 minus 2i, because negative 6i plus 4i is negative 2i, minus 4i squared. 6 minus 2i, I'm going to change that I squared to a negative 1. Okay, so that's going to be 6 plus 4 minus 2i, which is 10, right? So that's my numerator. 10 minus 2i over, okay? Now we're going to do our denominator again. So we're going to do our 2 and our 2i and our 2 and our minus 2i, right? 2 times 2 is 4. This is negative 4i, positive 4i. Negative 2i times 2i is negative 4i squared. Once again, you should be noticing that right here, these guys are canceling each other out. So what are we left with, guys? 4 minus 4i squared, right? Change that I squared to a what? Negative 1, right? So that's going to be 4 plus 4, which is what? 8. So 8 is our denominator. So here's my question. Can I stop there? The answer is no, because everything's divisible by 2. So when we write our final answer, we have to divide everything by 2. So we're going to end up with 5 minus I over 4. That is our final answer. So we're going to do these problems on the back, or additional problems just for practice, okay? So again, 4 minus I, right? Whoops. So we're going to multiply the top and the bottom. And I'd really like you guys to pause this video, do this yourself, and then come back to me, right? So this is going to be 36 minus 9i, right? Then on the bottom, again, hopefully by now you guys have seen the pattern, what's going to happen. So if I were to put this in my box right here, where I've got 4 in I and 4 in minus I, so that's 16, right? This would be minus 4i and plus 4i. These two are going to cancel each other out, right, y'all? And then this is just going to be minus I squared, right? So how we can get this, I want y'all to watch me here, okay? So we can just multiply 4 times 4, right? And then we can also multiply I times negative I. That's how we can simplify what's on the bottom pretty quickly, okay? So that gives us 36 minus 9i. This is going to be 16 minus I squared, right? So that's going to be 36 minus 9i. And what is I squared? That's negative 1, right? So this is going to be 16 minus a minus 1. So isn't that really going to be 17, y'all? So my final answer is going to be 36 minus 9i over 17. Okay? Let's do another. So here's another practice problem just for fun. Again, minus 5i, minus 5i. Go ahead and do this. Pause the video, see if you can solve it, come back to me when you're done. So this is going to be minus 30i over negative 25i squared minus 30i, negative 25 times a negative 1, right? So that's going to be negative 30i over positive 25. Here goes our question again. Are we done? No. Everything's divisible by 5, isn't it? So we're going to go negative 6i over 5. That's going to be our final answer. Okay, let's see if y'all can do the next problem on your own again. Go ahead and work it and then come back to me when you're done. I'm going to show it to you. Hopefully. Yeah, there we go. Go ahead and work this problem. Pause the video, work the problem, and then come back to me when you're done. All right, so here we go again. This is going to be 3 plus 7i over 3 plus 7i. Okay, so I'm going to use the box here because I like the box when it comes to doing a problem like this, especially the top. So we got 4 and 5i, right? 3 and 7i. Get 12 here, 28i, 15i, and 35i squared. So that's 12. Remember, again, we're going to combine these terms because they're like terms, so that's 43i. Then we've got the 35i squared. Going to change the I squared to a what? Yes, -1. Okay, so that's going to give me 12 minus 35, isn't it? Those are our like terms, plus 43i. So this is going to be 23 plus 43i. That's going to be my numerator, right? 23 plus 43i. Now, do y'all remember that trick I showed you last problem? So let's talk about 3 times 3. Okay, and then we're going to multiply -7i times 7i. Again, we've noticed that the diagonal problems, every time we've done these, have canceled each other out, right? So this is what we can do to short it. So 9 minus 49i squared, that's going to be 9 minus 49 times a -1, which is 9 plus 49, which is 58. So that is our denominator. And that's our final answer because 23 and 43 are prime numbers. I can't divide them by anything. Okay, we got one more problem. Let's see if you guys can do this last one. Again, just some extra practice if you guys want it. So go ahead and pause the video, do this problem, come back to me when you're done. Complex conjugate changes the sign in front of the imaginary part. I'm going to use my little box again. It's a minus, right, y'all? Okay. Hopefully you see some like terms here again, right here, right? So that's going to get me 14. 9 is 21 plus 6 is -15i. Then we've got this -9i squared. That's my numerator, right? 23 minus 15i. Remember my shortcut again. So now we're going to take the 2 times the 2, right? Plus 3i times -3i. Remember, this only works, guys, when we have the same terms with the plus and minus between them. So this is going to be 4 minus 9i squared, which is what? 4 minus 9 times a -1. So that's going to be 4 plus 9, which is 13. That's our denominator. Like that, another prime number. So that's our answer. So those were 4 extra problems for you guys to work if you wanted to. You could have paused the video before we got there if you wanted to, but I just thought I'd do some extra ones for you.